Okay, so last night the homework was starting on number 9. We're going to take a look at y equals sine 2 theta plus 1. The first thing that we have to know is how to put it into the graphing calculator. So it's very straightforward. There's nothing in parentheses. So when you do the sine of theta, you do close your parentheses at that point, and then we're adding 1. Now let's take a look at the window because this is going to be moving up and down a total of 1. Okay, that's the phase shift. So we know that it's going to be going up 1. So we have to have the x and y axis, or the x-axis is still going to be 2 pi, negative 2 pi. So that's fine. The x scale is pi over 12, so that's fine. But the y minimum, that was set for another problem. So I'm going to go to negative 1. So the minimum is going to go down negative 1. The maximum, I'm going to change that not to 2, but I'm going to do 2.2 just so it doesn't quite hit the top. The scale we're going to count as 2/10. So let's take a look at the graph, make sure that we have it. It didn't go high enough. Okay? Why didn't it go high enough? Even though it was shifted 1, it's twice as high. So we're going to have to bump that up. The window, instead of 2.2, let's do 3.2. And there we go. Now you might be wondering where the trough and peak, where they start. It's right in there. Well, let's try to get that in the graphing calculator. When we hit y equals, the second equation, as Sherry told us, we can just have it equal a constant. That'll give us a horizontal line. And there it is. Right there. Now don't get confused. That's the line y equals 1. And this here is the x-axis. Okay, so let's transfer this to the graph paper. It does start right here at 1 and finishes at 1. This value is negative 2 pi. That's 0. That's 2 pi. So since I wanted to go, this is a total of 12 marks. 12 marks. I know that that's 6 at 1. Okay, now I can put 1 right there if I want to, but why don't I just make that a half? I'm going to make that 1, that 2, and that 3. That's negative 1. That's negative 2. So I grab these points. We have it right there, and we have it 6 over. 1, 2, 3, 4, 5, 6, and then we have it 6 over again. We have a maximum right there, right in between these 2 points that we already put down. Maximum right in between 1, 2, 3, maximum at 3. Okay, we have a minimum right in between the 2 stars. 1, 2, 3 at negative 1. Okay, now let's draw this nice and smooth. Okay, what I try to do is I try to draw the parabola or the bowl, then I can connect it. Now this is going to be the center. This is the other bowl right there. Now we're going to have another peak. We got to grab that peak and that trough. Okay? So from this spot, I counted over 6 and went to the top. From this spot, I just went over, and then I went over another 6. So there they are. Nice and easy, smooth, 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 smooth. Okay. And there we have it. So because this is not an inverse function, the domain is going to be negative infinity to positive infinity. The range from -1 to +3, inclusive. The amplitude. Well, the amplitude is going to be half of that. From -1 to +3 is a total of 4. So the amplitude is 2. Okay. Now, how far is the period? If we take a look at the beginning of a wave, okay, from here to the end, that's one wave, and that's 2 pi. Because from here to here was 2 pi, so the period is 2 pi. Phase shift, it wasn't shifted anywhere to the right or left. Vertical slide, ooh, is this our first vertical slide? It went up 1. Vertical slide change, okay, and our amplitude change. Let's take a look at the next one. Okay, how do I type this into the calculator? I almost said computer. First thing we do is cosine. It automatically pops up the parentheses for you. Now, we have to take the cosine of all of that. Okay. So we're going to do the 2, then we do the parenthesis, then we do our variable, which is theta or x, minus pi over 2. Now I open up the parentheses twice, so I have to close it twice. Do I think that this is going to be going up or down any amount? I think it's going to be, since there's no number in front of the cosine, I think it's going to be going from -1 to +1 normally, but, and there it is, -1 to +1. Remember, my window was a little bit different. I said the but is that we have more waves on there. So I'm just going to clean that up a little bit. Okay, what I want you to notice is, the first thing I want you to notice is that this is a cosine function, but cosine is supposed to start at 1. And that's 1 because I changed my scale. It's not starting at 1. Okay, that's the bottom. So we have a phase shift. We have a phase shift of pi over 2. Let me see, this is 2 pi. Half of it is pi. Pi over 2 is right here. Oh, that's where it's starting, at pi over 2. Okay, so what is that? This is 6 marks. That's 3 marks. So pi over 2 is right there. Now it's going to start at 1, so I'm going to do a scale 1, 2, 3, 4, 5. It doesn't matter what you do, but I'm going to say that's 1. Down 1, 2, 3, 4, 5. I'm going to say that that's -1, that spot right there. Okay. I already have that as being pi over 2 at that location. Okay, so now we just start plotting. I notice that we have our minimum there and our maximum right there at pi over 2. So I go over 3, 1, 2, 3, go all the way down to my smooth, 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 smooth. Okay, that's the smartboard's fault. Smooth, smooth, smooth. Nowhere is this perfect. But practice makes it look better. So what do we know? We know that we have a phase shift. We have a phase shift of pi over 2. We have a change. Did I put that right for the amplitude? Just checking. There was no change in the amplitude because there's no number in front of the cosine. No change in amplitude. So the amplitude is correct at 1. Now, the period, how long does it take for a wave to complete itself? Once. So where does the cosine wave start? The cosine wave starts at 1. Where's the next time it hits 1? Right there. How many places are between it? 1, 2, 3, 4, 5, 6. Okay, we know 12 of them equals 2 pi. 6 of them equals pi then. The range, -1 to 1. You can read it right off the graph. Domain, since it's not an inverse function, is going to be -infinity to +infinity. Let's look at the next one. This one gives you the parentheses. So it wants us just to take the cosine of x plus pi. Doesn't want you to do the cosine of anything else after that. And then wants it to drop 2. I want you to think about the vertex form of an equation. So that's what we're going to be doing. The vertex form of a quadratic equation. So that's the same thing here. It drops it down 2, just as if the minus was in there. So now, if I hit graph, I know my window's off. This whole thing's going to be dropped by 2. So I know that it used to go down to -1. Going down 2 more has to go down to -3. Okay. The y maximum, well, let's see. Is this going to be going up any higher than usual? No. So I'll bet you the y maximum is going to be something like -1. So I'm going to put 0 in there, just so that we have a little bit more on the top or bottom. Okay, pull that out so we can take a look at it. Remember, I put this at 0, so that's the x-axis right there. That's the y-axis right there. Okay, now remember when I did my range on the calculator, that was -3. That was 0. That's -1. How do I know that? Well, let's pull up and right in between. I can hit y equals, and I can put -1 there if I feel like it on the next line. But what I actually feel like doing is putting in -2, and I'm going to make it. There we go. I'm all the way over on that line. I'm going to make it a very fat line so I don't get confused. Okay, so that did put it right through the center there. That's -2. Just copy it over. It's fairly simple to copy that one over onto the graph paper. Okay, there are a couple things I want to point out. Is that number 1, on the other ones, I forgot to put the x labels as -2 pi to 2 pi. And these do not make a, this is not a perfect semicircle here. So don't try to make it look like a perfect semicircle. Domain is still -infinity to infinity. The range, -3 to -1. Make that brackets. Amplitude. Well, -1 minus negative 3 over 2 is 1. So that's the amplitude. The period, we take a look at where a whole wave is. This is a cosine wave, so I look for the top because cosine starts at top. One full cycle. How many places is that? I count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 places we know on this scale was pi. So the period is pi. Phase shift, definitely. It was shifted over a pi value. Okay. Yeah, see, I hit pause and I started to think. It's like, wait a minute. The phase shift and the period, if they're the same, then it should look like a regular cosine wave, but it's not. Okay, so Mr. Bryce just corrected himself. 12 is from here to here. That's 2 pi. So the period is 2 pi. Vertical slide. This is supposed to be the middle, right? We had a vertical slide of -2 or down 2. Okay, starting on the next one, I already put in the 1/2 sign. Now I need the 2, and then what? I put in another open parentheses, x plus pi over 6. Close not one set of parentheses, but 2 sets of parentheses. And then I do -1. Why do I close 2 sets? Because I opened up 2 sets for the 2 and for the angle. Okay? Now, this is going to be squished a little bit. Okay? First of all, when I go to the window, since it's just going to be squished a little bit, it's going to be dropped down 1. Okay, why is it going to be dropped down 1? Right there. It's going to be dropped down 1. So instead of from 1 to -1, okay, I want this to be at least -2. I can do 0. We can leave it at 0. Okay, so now let's make sure that we see our window. We know what we're dealing with our window. So the y minimum is -2. Well, -2 is all the way to there, and that's 0. 0 to -2. Okay, so if we know that's 0 to -2, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. 10 increments. Each one must be 2/10. Oh, that's what we set. There it is, y scale. 2/10. Isn't that nice? So let's try to figure out where that is. To me, it looked like it was right in between 2/10, 4/10, 6/10, right in between 4/10 and 6/10. What did I do? Did I change the scale? Hang on a second. I put that on the wrong line. I didn't put it on y2. I put it on the end of the equation. So I multiplied my equation by -5/10. So come on. Sorry about that. Just had to type in the equation properly. Second time I did it, the -1 wasn't there. Okay, so that top spot is -5/10. So I know that that truly is 5/10, or -5/10, and this is -1 5/10. Because it's up the same increment. Okay. So now let's answer some of the more important questions that I feel are important on this question. From negative infinity to infinity is the domain. The range is negative 1.5 to negative 0.5. The amplitude. Okay, well, the amplitude didn't change. Actually, it did. Sorry. Between these two numbers, it's a total distance of negative 0.5 minus negative 1.5. The total distance of 1. We have to divide it by 2. That's the amplitude, 1/2. Okay, now let's count the period. This is a sine wave. So sine starts on the origin and heads up. There's 1. There's 2. There's 3. Uh-oh. Now we got some left over. What if I were to take this, put it right there? There's 4. There's 4 of them in a total of 2 pi. So 2 pi is the total. There are 4 waves. That simplifies to be pi over 2. For a period. Now let's see if we can do this, starting to think, starting to apply everything that we've learned. Okay, the x min and max is still going to be negative 2 pi to positive 2 pi. The scale, you can either do pi over 6 or pi over 12. Now here, this is what we want to know. What's our minimum for the y? We know that we're shifting down a half. We're going down a half. Okay, so normally, instead of going from 1 to negative 1, sorry, I had to answer the door. So normally, a normal sine wave goes from 1 to negative 1. Now we know that we're shifting down a half, so that means that it's going to be going from a half to negative 1.5. Oh, wait. It's going to be 3 times the size. So it would go from 3 to negative 3 normally. Has to shift down a half. So we're going to go from 2.5 to negative 3.5. Okay? So that's the x min and x max. X min, negative 3.5. X max, positive 2.5. That's why we're doing this whole thing. Okay, we're trying to be able to focus on the equation and know that first thing, it's going to multiply the amplitude by 3, and then it's going to shift it up or down. Okay? And that's exactly what I did. That's my table. And what's the graph look like? When I hit graph, isn't that beautiful? How do you graph it? You notice that it's a sine curve. A sine curve starts there. Oh, this didn't start at that spot. Okay, so now here's a little problem. That doesn't look like it's bottoming out right at the x-axis, or the y-axis, sorry. So you got to stop and, oh, look at that. Pi over 6. Pi over 6. It shifted it, didn't it? Yes, it did shift it. Okay, so that's why it's not hitting right at the bottom, right on the y-axis. The minimum It's not on the y-axis. Let's take a look at something else. Pulled up the calculator, put it onto a fat line, had it at negative 0.5. Why did I do that? I did that because that is where the curve is starting, okay? And it's not starting at the x-axis. Half of the curve is below that line, half the curve is above that line. Okay, we're doing good. Now, I want to figure out where that spot is. That's where sine is starting. Okay, so again, very intelligent student said use trace. Now, I'm going to use pi over 6. Second, pi divided by 6. When I'm in the trace mode, that shows me, hit enter. Bingo, bingo, play the bongos. The trace is right there. It tells me it's right at negative 5. So this whole curve was shifted to the right pi over 6. That's the shift. Vertical slide. Negative 1/2. Okay. The period. Let's hit that in a second. Amplitude is 3. Okay, have you thought about the period yet? The period. You got it. Okay, that's 30 minutes. I'm going to stop the recording here. Okay, I lied. Let's take a look at number 16. Okay, number 16, we have I have it typed into the calculator already. If you notice, I have a horizontal line at negative 2 also. When I graph it, it'll graph the curve. Interesting, interesting, interesting. Now, what we're supposed to have, we have a phase shift of pi over 2. Okay. So right about there is pi. Right about there is pi over 2. Well, you know, cosine looks like that. Well, this looks like it's starting at a minimum instead of starting at a maximum. That thing right there. Okay. What did that do? Did that affect the amplitude? Did it affect the period? Okay. That affected the vertical slide. This affected the phase shift. What did the 1/2 do? How many waves do we have here? Cosine starts there. Oh, did it really end right there? No, it came back up to its maximum right there. There's only one wave in 4 pi. It starts at a maximum, ends at a maximum. This is 2 pi. This is negative 2 pi to 0. So that's a total of 4 pi. So I just threw the cosine wave up here, and we see that one full wave is through 2 pi. 2 waves are through 4 pi. So the period is 4 pi. I think that's gonna stop it for now because the class period's probably over. You have a great weekend.